All right, well, good morning. Hope you all enjoyed your evening last night and the sessions that we had yesterday. Just briefly, a few housekeeping items. As was mentioned yesterday, if you would, make sure your cell phones are put on vibrate or silent. And also, after this session is over, if you've got any coffee cups, water bottles, or any other trash or waste, if you wouldn't mind putting in some of the receptacles outside the room. So I'm very pleased this morning to kind of kick off our session on day 2 of our concurrent sessions. I know when we first started planning this program for this year, which started actually in 2019, one of the requests was to try to get more engagement and involvement from some of the academic community, and so this has been a central piece of what we wanted to incorporate into this year's program, so I'm very pleased to have all of our participants here today. So what we're going to do is we're going to have a panel, but with our researchers that we have, they're going to give a brief overview of some of the work that they've been doing, because some of you may not be familiar with it, and afterwards, when they will have lots of time for Q&A. But also wanted to spend the last part of it just talking about how to develop industry academic partnerships. That was one of the requests that was asked, is how can we get more engagement and involvement, because obviously a lot of what we do is research, based on research, and so I'm really excited about that. The panel will discuss how integrated veg management supports native biodiversity along right-of-ways in different regions in North America. And I'm very pleased to introduce, I'll start off with Carolyn Mahan. She's going to moderate the session. Dr. Mahan, I've had the privilege of knowing her and working with her for a number of years. She is a professor of biology and environmental studies at Penn State, Altoona. And her PhD is in wildlife science from Penn State and a BS in natural resource management and engineering from University of Connecticut. She's done a broad amount of research. She's well published, and she served on the board of the Pennsylvania Wildlife Society and is past president of the Pennsylvania Biological Survey. And I've had an opportunity to work with Carolyn for about 12 years with State Game Lines 33 and Green Lane, so very pleased to have her with us and the rest of our panelists, so thank you very much.
Thank you, Travis. As we wait for the first slide to get put up, I want to just, there we go, wow. I just want to comment on these panelists that are here today. I just was asking them before we got started about how long they've been working on rights-of-way. And so there's 70 years cumulative experience up here on rights-of-way research, primarily in the East Coast, to be quite honest, but also Dr. Halley is here from Sonoma State, so information about California will be presented to you as well. I also wanted to say that really the point of this presentation this morning is to do just very quick overviews of our research. You can find our published papers online. Several of us, our research teams, are giving additional talks today. Dr. Carnes is talking at 12:45 as part of a research symposium, and Dr. Stout, who works with me, and she's an entomologist, she'll be talking today at 3 o'clock. So if you want to read more details about our research findings, you can do that or speak to us after the panel. So as you can see on the slide, I have the list of people who are represented here today. And I've also listed their email addresses, so if you need to get in touch with any of them after the panel, you can do so. And finally, I've listed their corporate sponsors, corporate partners. You should be aware that these projects are really multi-partnership endeavors. You know, our universities support us. I know Kim, for example, has other support with Monarch Joint Venture, et cetera. But these are the major industry partners who have worked with us and continue to support our research on rights-of-way management. So this morning I'll start us off, and then Kim Russell from Rutgers University, and I'll introduce each of the speakers that will be speaking to you. Gabe Carnes from Ohio State, Chris Halley from Sonoma State, Ben Ballard from SUNY in New York, and finally, Mark Scuccetti could not be here, but I'll be presenting his research findings this morning. Okay, next slide, please. Oh, sorry, I got this. There's a remote. So I also want to say we're going to be talking a lot about integrated veg management and how integrated vegetation management under rights-of-ways can support biodiversity. But we need to first be thinking the same thing about integrated vegetation management, about how we think of it as academics, so that we're starting from the same place. We'll mostly be calling this IVM. I took this definition, I thought it was a pretty good one, from the EPA website. The EPA is now supporting integrated veg management as ways to manage industrial, human-modified landscapes for biodiversity. So you can see it's the practice of promoting these desirable, stable, which I think is very important, low-growing plant communities that resist invasion by tall-growing tree species through the use of appropriate, environmentally sound, and cost-effective control methods. These methods can include a combination of chemical, mechanical, biological, cultural, and other methods. I also think of this as we're trying to get sites that are dominated by native species, native plant communities. That's not always possible in all of our landscapes, but the domination by native plant communities is a goal, and the reduction of non-native invasive plant species. The compatibility idea, though, is defined by industry. Okay, so compatibility is what is compatible with a gas line right-of-way versus what is compatible with a transmission line right-of-way. Those are different things depending on the industry's regulations, for example. So since 2014, I've been the lead investigator on the State Game Lands 33 research in central Pennsylvania. And this research I think, the initial research into integrated vegetation management on rights-of-ways. We have 65 years, a little more than 65 years of data on these sites. And this has been continuous research. So we have amazing data sets on birds and plants, now pollinators. And this work has been supported continuously by industry partners and, of course, Penn State University as well. This photograph, you can see the classic wire border zone method where the area underneath the transmission wires is kept low. Low vegetation dominated by forbs in our study site, and then it transitions into these border zones where shrubs are permitted to grow, and then into the neighboring forest, which is outside the right-of-way. So this long-term research, as I said, it's been continuous. We have an amazing research team. And one of the points I also want to make this morning is that this research comes down to people. We have amazing industry partnerships, but it's actually the people within those industries that make things happen. And I think everyone on this panel will agree with that. So that's why my current partners, I've listed them by name on this particular slide. These are people that take time out of they already have jobs to really promote and support the research that we're doing at Penn State. I also mentioned we can really explore what happens with IVM over time with these long-term data sets. And I always include this picture here because on the left-hand side, that's me in graduate school working with one of the founders of the project, Dr. Bramble, and we were looking at ground nesting birds using the right-of-way corridor back then. So it's, like I said, a long-term commitment by industry to this research. I said I'm not going to discuss all our findings, but we do have data sets on native plant communities, breeding bird communities as well, some of species of which are declining very dramatically in the Northeast, but are using the rights-of-way. Great information on pollinators, in particular native bees. We're starting some research on ground beetles to see how the soil community is affected under these transmission lines. And we also have past data sets on small mammals, game species, game birds. So a very complete data set from State Game Lands 33. I also want to quickly mention how this research can contribute to just general science. So just discovery, the science of discovery that we've had on this research, which is kind of a side benefit to the work that we were asked to do. So pictured here are 3 species of rare bees. The species on your right is the golden bumblebee, which has been declared, and probably will go extinct or is predicted to go extinct by the IUCN in about 65 years without intervention. And we're finding them using the rights-of-way. And right now we are working with the USGS to describe a new species of bee, a nomada species, new to science. So these are species that we found just in our research on how IVM is promoting native plant communities and how those in turn are promoting pollinator communities. So again, with this last slide, I'm going to direct you. This is our website. You can see right at the bottom, our website is listed. All the different topics of research that we have at State Game Lands 33 and a sister site down by Philadelphia, which is called the Green Lane Research Site. So if you are interested in specific scientific papers, reports, other talks that we have given, a summary of our findings, please direct yourself to our website. Okay, we're not going to take questions now. We're going to just move on to the next panelist. And our next panelist is Kim Russell. She's from Rutgers University in New Brunswick. And she's been conducting research on rights-of-way for about 23 years. And I've been really impressed with her work, with recent work with pollinators, and her ability to engage not just her industrial partnerships, but local communities. So.
Let's see, how do I change the slides? Oh, just here.
They'll do that back there.
The green? Okay.
Yeah.
All right. Well, thanks, Carolyn, and thanks for inviting me to speak. I'm always excited to talk about my work in transmission lines. So as Carolyn said, I'm an associate professor in the Department of Ecology, Evolution, and Natural Resources at Rutgers University. I consider myself a community ecologist. In graduate school, I became interested particularly in the conservation of invertebrates, particularly in the terrestrial realm. I quickly learned that though we love our charismatic vertebrates, that the real thing that's going to make a difference for us as humans and for the wider community of plants and animals, we got to look at the little things, right? And so that's where my niche came. And as you can see from my graphics, I've started out with spiders in graduate school, and now I do native bees. And I'm going to be giving you an overview of my research. I'm going to speed through some stuff, but I'm hoping you're going to all take away some nugget of new knowledge that maybe you didn't have before. One thing about native bees, I keep using that term, is, again, there are still people that don't realize that honeybees are a non-native species. The honeybee industry for pollination really came about because of the decline of native pollinators. And they were brought over for their honey and then have been conducting the service. So my research is on native bees because we don't have a whole industry to support them. Honeybees live in hives. We work towards them. We have a lot of people working on that area. So my specialty is the native bees and the community of them. So lots of things are threatening. This is no news to most of you in this room, I'm sure. You've heard about this in the news. There are lots of threats to our native pollinators. I chose really to focus on 3 things that could be locally managed, and this is the focus of my transmission line work. In addition to providing food for foraging pollinators, we also need food stability, which Carolyn mentioned. But one of the things that I'm going to drone on about is nest site availability, because it's not enough to give them food. Flowers are easy. You need to give them a place to live. Now, most people don't realize that native bees don't build hives. They build individual nests, either in the ground or in cavities. There's some pictures here. And also, most bees don't really like to travel very far from their nest. They need a place to live and a place to eat, all in the same place, all in the same area. And so this is kind of where I'm coming from. And in terms of pollination services, there are, of course, other pollinators. But bees are I like to call them the workhorses, They're the on the ground doing the majority of that, especially for agricultural systems. And so that's kind of why I'm focused. But the good news is managing for native bees is probably going to benefit a lot of the other pollinators as well. So I really started working with pollinators originally with Sam Droege at the USGS when he was just starting out, and it was sort of like, hey, you know what? All the cool species are in power line cuts, all the sun-loving species, and that was sort of a known thing, but we hadn't really been quantified it in any way. So I worked with him on a paper, and then this rolled into an EPRI-funded study that was a 3-year study. It was actually across multiple areas, but I focused on Maryland for this paper that I published. And again, we had the opportunity because in Maryland, in the Patuxent Wildlife Research Center, you had some lines that had been managed with IVM for many decades. And then also they had some new initiatives, B&G&E had some new initiatives. So it allowed us to compare sort of newly managed, a couple of years IVM, old managed IVM with what I can consider the control, which were the annual mow or the episodic mow. And so what we found, we conducted bee surveys over 2 years across the season. Many bee species are seasonal, so you kind of look at the whole community. And we sort of found what we expected a little bit, but it's science, you gotta prove it. You can't just go with what you think. And yes, all the cool bees were in the IVM sites, and the longer it was managed as IVM, the more interesting species you had there. Why do we care about interesting species? Well, you want a healthy bee community, a robust bee community that's gonna withstand and be able to bounce back from any problems, but still be able to provide pollination services. So again, just some data, the parasitic species, social species, specialist species, rare species were all much more likely to be found in the IVM sites. You also had a diversity of nesters, more stem and wood nesters, and I'm going to get to that in a minute. And you had more smaller bees, and you might be like, why do we care about small bees? I like bumblebees. Bumblebees are awesome. Well, the thing is, bumblebees can travel great distances to forage. They can travel 1 kilometer or more. Honeybees can travel great distances. Small bees, though, they're not going to fly more than a few meters likely from their nest site. And so if you find small bees in an area, they're living in that area. They're not just coming in from outside and foraging. They're building their nest there. And that's important if we want to create habitat for them. So I looked a little bit more into nest site availability and how IVM produces such good nesting habitat for wild bees. And you might think to yourself, well, why don't you just go and look for nests? Not easy to find the nests of native bee species because they're small, they're difficult to so you can't survey that, but you can survey the factors that are associated with nesting habitat. So if you can see on my figures, I'm not going to bore you with too much data, but we did find that the percent dead woody material, percent litter, and percent bare ground were all higher in the IVM old sites. Those are the sites that were managed for long periods of time in that mechanism, compared to the control sites. And then we also, on the bar graph there, you can see that the IVM old had lots more woody cover, but also lots more percent litter and dead woody material. And all of that are what bees are using to build their nests. And so, our conclusions for that study were that, the management style does matter. Yes, power line cuts are good for bees because of the sunlight, but you can do well with IVM and in terms of it being superior in terms of creating good, robust bee communities with nesting habitat and flora resources throughout the season. And then I was also curious about how transmission line rights of way compared to other open habitats in the environment, either parks or prairies or even just abandoned old fields. So I did a study where I collected in both areas. This was also part of a study trying to understand the effects of EMF potentially on bees. So you had sort of out of EMF fields and in. In any case, what I found is that in some places, these open habitats, in most places, the transmission line had higher richness, higher bee abundance than these isolated patches of open habitat around the landscape, in the similar landscape. But the problem with those, even when it was equal, the benefit of transmission lines is this consistency, right? Consistency in management. Most of those other habitats I was looking at, unless they were actively managed, are going to just grow up into woodland, and that's not good. They're going to lose their value for the pollinator community. So that was just another aspect of the work, is trying to compare those things. And then the most recent work I'm doing now in New Jersey with PSE&G, where I'm more actively involved actually with the manager. So PSE is more actively involved than BG&E was. Can we do more than just IVM? Like, what are the benefits? There's been a lot of talk about pollinator mixes and spreading pollinator mixes, and maybe that's a way to promote habitat on rights of way. And so we're like, well, let's look at that. Let's look at maybe doing seeding first before IVM commences. Let's look at maybe doing a cut stubble treatment to get rid of some of those woody invasives and then do IVM. And then, then there's another level up from that, which is maybe we need to control the invasive species, maybe not the tall growing ones, and put in plugs or shrubs or seedlings to try to give those native species a leg up because they're important compared to the others, right? Those invasives come in and cause a problem. And then, of course, both of these studies require a cost-benefit analysis because, money is limited and you want to promote something that's going to be usable and implementable over wide areas. And so you don't want to invest a lot of money in something that's not going to give you much bang for your buck, right? Maybe it's better to work with the species that are already there instead of bringing in pollinator mixes. So these are some of the questions we're trying to answer. Just briefly, the first site, we had 9 sites spread across New Jersey, 3 of which were raked and seeded and then mowed for a few years to enable us to compare those to the straight IVM or the cut stubble IVM. These were some pollinator mixes that were provided to us by a New Jersey firm, so it was local. That's part of the issue with pollinator mixes. And we don't have data for this yet, so I can't really tell you. My gut, though, is that it's difficult to get pollinator mixes to establish just by spreading seed in just a random area, right? We've come to the thinking that it's better to sort of do a plant survey, see what's already growing there. Plants are finicky. They like certain soil types. They like certain hydrology regimes. Not every pollinator-friendly shrub is going to grow in every right of way. So now we're thinking, oh, maybe we need to do plant surveys, see what's already there, and then try to promote those species because they already can grow in that area. And so that involves some botanical knowledge. So this next level is a project that I'm quite excited about. It's just been going for a couple of years because it involves not just PSE&G and Rutgers, but Garden Club of New Jersey Tree Foundation, New Jersey Audubon, all these organizations that want to promote this habitat and rights of way and are willing to put some money and manpower towards it. Because that's what you need if you're going to go to the next level, right? If you're going to put in plugs, you're going to put in seedlings, you're going to do these floristic surveys, you need more support, right? And so this is a cool project. We've got a few sites, high profile. Many of them were overrun with some non-native species. And just to clarify, not all non-natives are bad. There are some non-natives that provide good resources for birds and bees, but there are certain things that really provide nothing. And for New Jersey, that's mugwort. It's the bane of our existence because it provides nothing for bees, but it crowds out all the beautiful, shrubs and plants that do provide resources for bees. So part of this project is we're like, how do we control the mugwort effectively on rights of way? What can we do? It's not something that would normally be a target because it doesn't grow very high, but it's bad, right, for bees. And so we're working on that. And then we're also, of course, doing bee diversity analysis, trying to see if we can find a shortcut by doing a floristic quality and see how that maps on to the bee diversity. But I'm just excited about it because we've got so many partners and we are sort of evolving to that approach of seeing what's already there and then promoting those species, those bee-friendly species that already can grow in a particular area. Come on, next one. Just briefly, because I know I'm out of time, I did look at EMF, as I mentioned before, through the EPRI-funded program. I did some studies on the foraging behavior of bees, pollinator efficiency, their ability to pollinate plants, and larval development, because really wanted to see what's going on with some of these papers that have come out in the last few years that have really been alarmist in terms of EMF and honeybees and what's up with that. And in my work, I didn't find any evidence that EMF negatively affected bees in a measurable way. That doesn't mean it doesn't affect them at all. It means that the availability of resources is more important than any potential negative of EMF. So why did this other study find such a big issue? Well, they looked at honeybees, whereas I focus on wild bees. But honestly, many beekeepers lease land from power companies to put their hives in, and they report that their hives thrive. So it seems unlikely that that's an issue. I think it's just about field versus lab conditions. All my research was in the field, in actual EMF fields that were measured outside, not in an artificial environment. Those studies, they were looking at 100 to 1,000 microteslas. But exposure underneath the power line where the vegetation is probably only going to be about 5 microteslas, unlikely to affect bee behavior because you have that ameliorating effect of vegetation. And there's some other issues with that study. But the point is, I always try to calm people down about the EMF because I don't think it's that relevant. And then finally, since there's some interest here, I've mentioned all this about getting species level data for bees and looking at the whole community as being really important to be able to measure the effectiveness of some of these treatments. Genus level, higher level IDs are not as good because they don't let you really evaluate the robustness of the bee community, but it's also really hard to get IDs. And so I've been working on this for actually a long, long time, but using deep learning and artificial neural networks to do an automated ID system where you could easily take a picture of a bee wing and then feed it into the system and get an ID back. So this is another project in development. And this is, just to give you a feel for how difficult it is to separate species. These are two related species, and literally look at those two pictures. They're different, and that's the diagnostic character. You're like, wait, what? So that's why you got to send off the bees, and it's expensive and whatnot. So hopefully I'm going to continue to work on this project to find an easy way, because it's, again, you can train an undergrad intern to take pictures of bee wings and get your IDs. Okay, I've gone over, but thank you very much.
Thank you very much. Thanks so much, Kim. As I said, she's doing amazing work. She's worked in New Jersey, Maryland. She also has some experience in Wisconsin and Oregon. So if any of you here are interested in some of her findings from those places, she's also worked there. I also wanted to comment, she mentioned her work at Patuxent, where they had long-term IVM. And if you noticed, she mentioned that long-term management, actually, it's that consistency that really supported these diverse, robust communities of pollinators. So that's why this long-term consistent treatment is really critical. And we need these long-term research projects to see that. So our next speaker is Gabe Carnes. He is from Ohio State University. He's worked with transmission line biodiversity response to IVM, but he's also started to work with gas companies as well. He has a recent grant, a recent contribution from Marathon, and he's expanding this work in rights-of-ways into gas line rights-of-ways, which I think is a very important aspect of his work. So, Dr. Carnes.
Excellent. Tough act to follow. But I want to highlight the fact that, well, I do want to draw attention to the fact that on the initial slide there were a couple primary leading partners mentioned. But this is a partner-rich sector. The way that the big players often are working with middlemen and liaisons and subcontractors and on down the line, the actual people on the ground, it is a partnership-rich sector, and that is truly a pleasure to work in. Because too often in the university world, research is driven by isolated dyads. It's like, I'm a PI, and I have a partner, and other than me and them, no one else in the world actually knows what we're doing. Research in this space is quite the opposite. It's quite the opposite. It's a unique mixing of the researchers with environmental consultants, with the top-down managers, with the bottom-up practitioners, and it's a unique combination to come to a conference where you can find all of those elements mixing. That's exceptional. The other thing that I want to mention is that you likely view a university as primarily a research institution. Certainly, Ohio State is one of the preeminent R1 land-grant institutions. However, being a land-grant institution actually means that we are charged with 3 primary accountabilities, research only being 1. The other 2 are teaching, which I look forward to this conversation, this panel moving to how do we engage with your next wave of professionals, my students today. But the third element, research teaching, is extension. And those are 3 clearly articulated charges that a land-grant university must honor. So when I hear Kim presenting research, that downed woody material provides that nesting habitat for bees, if that's simply disseminated in a research platform, that probably short-circuits the ability of folks I work with who are extension specialists training in-field practitioners to not ask first, hey, there's probably going to be a lot of slash when we co-locate that second line, or when we get sort of the edges back into compliance, what do you want us to do with the slash? Because chances are, I either want to chop it up for firewood and probably blow chips back into the surrounding landscape, but the last thing I really want you to do is leave the slash in place. Well, what if university extension and framing it differently now sounds like this? Are you interested in your property, through us having visited, to be more pollinator friendly when we leave? Right? That all of a sudden changes the equation from a I'm predisposed to, yeah, that stuff needs to be gotten rid of, to, what if we strategically piled the slash and let natural decomposition, and now the landowner does not view that as a nuisance, but now views that as an asset and something to brag to their neighbors about, haha, my property is pollinator friendly and yours isn't. But if it's just research, we don't connect the dots with that extension selling point and bring the community into these smarter solutions that sometimes, quite frankly, look like working smarter, not harder, which is a wonderful message to be able to tell. All right, so how do we advance this? I mean, I have a PhD, but all right. One thing academics are excellent at is overcomplicating things needlessly. Guilty. So we're going to try to keep this simple. In 2017, 18, and 19, thankfully not in 2020, we wrapped up this study right before everything got pandemicked. We identified 24 sites in eastern Ohio. Eastern Ohio is a fairly fragmented ag and pasture forest mosaic. Ohio is extraordinarily parcelized because it's highly privatized, which means lots of diverse stakeholders. This work was done on the heels of major pipeline infrastructure expansion to accommodate horizontal fracturing technology, which hit eastern Ohio like a freight train. Right? As a wildlife ecologist, our lab was asking questions: what single driver is changing our landscape more than any other thing? And in eastern Ohio, it was the rapid acceleration of linear pipeline footprints. Now, the nice thing about this is that we were not predominantly concerned with pipelines that have been on the landscape for 40 or 50 or 60 years and may or may not be in need of significant reclamation. We're talking about pipelines that are only 4 or 5 years post-construction and haven't honestly had that much time to get super out of whack. The other thing to point out here is that because we're dealing with pipelines, if you think about grasses and legumes and forbs as 3 pie slices within a pie, notably, woodies are missing. It's because this is a pipeline, okay? And it's a new pipeline. Those woodies, despite Ohio's somewhat infamous woody invasive shrub community problem that we have, and we're not proud of, that woody component was simply not present. So as a wildlifer, if I'm thinking about this pipeline predominantly from the viewpoint of how do I get habitat on the ground for pollinators, that can look like 2 different things. Either I want to spend a little bit of money, but eat at Cici's Pizza. Okay, do you remember Cici's Pizza? Like $2.99 buffet, eat till you drop. But all we serve is pizza. Or take your better half out for an anniversary dinner and you spend an exorbitant amount of money and eat little teensy, very diverse offerings in a 9-course meal. Now, those are 2 very different strategies of acquiring calories, but if we think about abundance, there's 2 ways to gain abundance of flowering resources. One is clover, one is forbs. And quite honestly, forbs in a lot of situations, cannot hold a candle to a legume-rich dominant system. But here's the problem. While it's fun to eat at Cece's for $2.99 once, thankfully, if you decided to go there every Wednesday, eventually you'd find out that that Clover buffet has gone out of business. So Clover, while it is a prodigious producer, it is also a pulse producer. Clover, in fact, does not have any significant relationship to supplying a diverse menu of pollinator resources. Forbes is the only gateway that gets you that. Okay, do you see that? So I'm going to try to dumb this down. Within a right-of-way, overgeneralizing, of course, within a right-of-way, if you can shift and increase the pie slice that is composed of native forbs, end of story, almost without exception. Because what that likely means is that you've reduced cool season or warm season grass components, which have their own benefits, but if you've drawn your bullseye on this is a site where we're elevating pollinators into a place of priority, that's how you do it. Diverse menu, because host plant associations, and diverse menu because plant phenology arcs from the beginning of the growing season until the end. And if you've hooked your pollinator resource wagon to Clover, you've got a lot to brag about for a very condensed time window. You're like, man, he said he was going to keep it simple. That doesn't look simple. Oops. You're like, and I didn't, so I'm getting rid of the slide. No. Here, if we think taxonomically, how are wildlife responding? We've kind of come at it from the other direction. So butterflies. Is bloom abundance positively associated with I'll see more butterflies and I'll see more diverse butterflies? Turns out yes. That's why there's a red plus mark. That's a positive association with bloom abundance. But, and you notice the size of the coefficient is much larger, bloom diversity is the big payoff for more butterflies and more diverse butterflies. But in wildlife, the thing that I beat into my students' head time and time again is that the phrase wildlife friendly is a misnomer. It can't be wildlife friendly. Because I know that as a wildlife ecologist, if I draw my, you know what I'm really excited about? Ruffed grouse. Or, you know what I'm really excited about? Winter range mule deer. Or you know what I'm really excited about? The Delhi Sands fly that I didn't know existed until the first talk that I attended yesterday morning. As soon as you make the habitat better for ruffed grouse, you've said, hey, this is going to be my winner because of what I'm doing. You're also moving the needle away from species that are now less favored. Because thankfully, all wildlife are not generalists. And most generalists do not need our help as much as specialists. So it's very okay to say butterfly friendly. But if I say wildlife friendly, and then you start bragging about your pollinator friendly, in the back of my wildlife ecologists' minds, I'm wondering, man, as they've honored the desires of the butterflies, and they've dedicated spaces on the widest right-of-ways to that objective, you know, that's probably where our salamander populations are taking the punches the worst. So wildlife are winners, wildlife are losers. Our job is to think about right-of-way management from an ecologically nuanced perspective. Not just looking at the site, but accounting for the surrounding landscape and identifying which wildlife would be best served by the conditions I see here and how this site is networked with the broader landscape, and in so doing, also realizing that there's some species for which, whatever you do, life for them will be more difficult. And thinking about, is there ways that I can mitigate those impacts and really doing justice to wildlife friendly from an intelligent standpoint, not sort of a, well, I can name a wildlife species that it's friendly for, therefore wildlife friendly. Those are very different approaches. Finally, I'd strongly encourage you after lunch to join us at 12:45 to 2 o'clock for another panel to discuss the toolbox associated with the IVM 3rd edition vegetation or compatible addendum, compatible companion. This industry has been oriented towards dealing with incompatibles for a very long time, and that will continue to be a mainstay. How do we deal with the bad stuff? Thankfully, and I see it as a sign of great progress, this is a bragging point when I talk about students who are very conflicted and can't understand how this professor who talks about being really interested in environmental stewardship and conservation and dedicating his life to the conservation of wildlife and wild things could partner with someone like Marathon, right? Or partner with someone like Bear. That's a very real concern for our students, for our younger generation. I would like to politely say they're not mature enough yet to understand that when the Lorax was on the stump, screaming and hollering and jumping up and down and accusing the Onceler of being an evil human, at the end of the book, I actually have not seen the movie the whole way through, but at the end of the book, guess how many trees the Lorax saved by adopting that approach? Not a damn one. So there's lessons to be learned there. We need the young generation and we need their passion, but we also need pragmatic solutions that meet in the middle. I think the students, I think the younger generation would probably look at this sector as saying, oh, we're in the middle and we're waiting on them to meet us here. And I'm imagining that plenty of us within this room are thinking the exact same thing. That's a challenge, and as a university, mentoring and speaking to students from a very, this is how conservation actually works, like this is how it looks like in a textbook, but this is how it looks like in a state, Ohio, where there's 13 million people and highly parcelized, and the fragmentation ship is a long ways out of harbor. In fact, I can't even see it. It's a little speck on the horizon. Like, what does conservation look like there? Working Landscapes, this sort of a conference brings that to the crucible, and I'm excited to see where these partnerships can grow as we move forward together.
Thank you, Gabe. And as he mentioned, he'll be speaking again at 12:45 this afternoon, so you can hear more about his work. He makes an excellent point that we often forget. All management activities have trade-offs, and we see that in our own research sites, and I think all of us can attest to that as well. Our next speaker is Dr. Christopher Halley, who comes from Sonoma State, our only West Coast representation. He's been working with two great partners in California, SMUD and PG&E, and he's been studying rights-of-way transmission ecology, I think in a very challenging landscape. I had the opportunity to visit some of his study sites several years ago. Just very challenging in California with the long growing seasons, fire risk, different issues that we deal with on the East Coast. He has study sites in alpine habitats, mixed oak habitats, and today he's going to be mentioning, just kind of talking about part of his work, which is using remote technology to look at wildlife using these rights-of-ways. But he's done a lot of research, so this is just touching the top of it. So if you would like to talk to Dr. Halley after his talk about more of his work, he'll be available. So, Chris.
Hello, everybody. Better start my timer here. Yeah, thank you for having us. And I'm one of the odd ducks up here in that I'm not a card-carrying biologist. I'm an engineer, climate guy, oceanographer who's been going back and forth between industry and academia for about 40 years now. I worked for some large energy companies like Exxon and Woodside and Chevron along the way. So I'm fairly familiar with the energy industry. And this, as Carolyn said, is just part of our work. And I tend to be project agnostic, so I'm leading the right-of-way effort on the West Coast. And I kind of look at it as a lens through which to get students involved in real-world projects because they're looking for something to do. They obviously need that experience in school. And so if they can contribute to some sustainability issue or some larger issue, I think that sets them up for success, and we benefit from some of their ideas. And that picture on the left is actually me up in the Arctic back in the 90s, I think. And as I said, we try to get everybody involved in real-world projects. Our preserve I'll be talking about today is the Fairfield Osborne, and it's near San Francisco Bay. So there's a lot of topographic variability. It's not a forest that we've cut a right-of-way through. It's very patchy. And some of our sites have actually burned a few times in the past couple of years, and that's been pretty exciting. It's a collaboration. And I'm not going to be talking about our point transect mapping or our pollinator work or anything today. The focus of this is really how we got some tech students involved. And as part of this work, we deployed 6 cameras across the right-of-way. And the challenge, of course, is that when you deploy wildlife cameras, you get a large number of false positives, right? Because the motion sensors are triggered by leaves blowing or by clouds moving across the ground or anything like that. So we have 6 cameras, and we ended up with about, 12,000 false alarms and about 13,000 actual pictures of animals. And if you go through, frame by frame by frame, just those, 12,000 false alarms can take you 3 or 4 weeks, which is a lot of time. And so we asked some students if they would develop an artificial intelligence system to screen those out for us. And I'm not going to go into the model too much. That's okay. Other than to say we use something called transfer learning, which I know Kim's familiar with. And the idea behind this is you repurpose other models for your particular application. So you can actually set up and run a model within about a half hour, which makes it perfect for a guided class project. Oh, there it is. So our data set was obviously pictures, and this complicated slide is just to remind me that we did indeed have 12,000 false alarms. But as you can see, the cameras are set up to take 3 pictures in a row and then rest for 10 seconds. And the idea is that if you get 3 pictures in a row, you can get a picture of an animal transiting the frame. If you have a squirrel that's playing in front of your camera for hours and hours, you can get thousands of pictures of a squirrel. So we didn't actually use these for detailed population estimates. We just used these to see if we could detect animal movement. Oops, there we go. We're just going to be talking about scenario A. We established a camera network and we applied a model to it. And this is generally what the data looks like from a computer model. We've got a series of 6 pictures out here, and the top left, I guess, there's a confidence score. It shows a score of 99.5%. So what the computer model is saying is it is 99% certain there's not an animal in that picture. And that seemed to work pretty well. The nighttime picture in the top center, there's this score of 62%, and the computer's 62% certain there's not an animal in that picture. So that's pretty nice. Now, if you look at the lower left, which is incredibly difficult to see, I don't think I have a pointer. Okay. It's a little bit difficult to see. The computer is saying it's 87% certain there's no animal in that picture. But if you squint your eyes and tilt your head just right, you can see that there's a coyote on the lower left-hand side entering the picture. So the computer model's not perfect. And so this leads you to think of, well, if I vary, if I select pictures based on a confidence score, what happens? How often is the computer right and how often is the computer wrong? Now this fairly complicated slide is what happens when you do that. So on the left-hand side of this, we said, okay, what if we use a threshold of 0.5, right? So everything that has comes out with a prediction of greater than 0.5, we're going to say that's a false alarm. What happens? So this black bar in the middle is nothing. There's nothing in that picture. And so we actually capture 90% of those false alarms if we use that threshold. So we've gotten most of the false alarms out of our data set. That's great. But if you go to the top of that picture, which says vehicle, it turns out we've actually, 80% of the vehicles we also classify as false alarms. So we're actually getting stuff that's not false alarms, and we're actually throwing that out of our data set as well. Now, if we decide, okay, let's use a threshold of 0.97, what happens? So, and that means that it has to have a value above 0.97 for us to consider it as an actual false alarm. Well, we're capturing half of the nothing category, right? So only half of the false alarms are we actually capturing, but we're not misclassifying anything else. And so these two views of the world are what a computer model allows you to do. So for research, you might be okay only capturing half of the false alarms. You've saved yourself half of the work. But if you've got a real-time education system, like you want to beam these pictures real time to partners or to community members, which we have to deal with. We have a lot of, and I guess I'm one of them, but we have a lot of tree huggers in Sonoma County that don't want you to do anything. And you want to say, hey, look, we've got IVM and we've also got animals. You don't want to beam them nothing. So you're okay getting rid of all the nothing category and misclassifying other things because you just want to make sure you're only sending them pictures of animals. So there are trade-offs you can play with computer models. And all of that is basically a way of saying that, we've saved a lot of time and, we'd like to, in the future, for this false alarm work, we'd like to do some multi-stage classification, use some different classifiers. But the real benefit of this, from my point of view anyway, is getting students to work on real-world projects. And this is a picture of Raffaele, my first student, first generation in college, and he really finally got interested in school when he did this work and went on to get a local job working in motion detection for a local company and is now helping his family out. And so, we're a minority serving institution, and that really makes a difference working with partners like yourselves. And in terms of what's next, like I said, I'm kind of project agnostic, but I think this is a great opportunity, like any real-world project, and it's to maybe expand this movement, if you will. There's an idea that keeps rattling around in my head to try to turn all of our sites into kind of a national network, right? So we call it a field station because we're part of a field station at Sonoma. And we call it a field station, and we work together so we can leverage expertise across all of our sites and get students and faculty and energy industry partners involved across all of our sites. And this, in the future anyway, would help us get more funding. And during COVID, of course, we set up a virtual learning platform where students can go and visit field stations around the world, literally, and learn how to observe and how to frame questions and how to ask questions. And we set this up based on the framework provided by the 4DEE ecological framework from the ESA. And so I think that using multiple sites, we can actually get students across the nation engaged and have partners help to train the next generation of students. So I just think this could be bigger and better, and I'm happy to talk more about that in the panel. So thank you.
You're right. I was really impressed with that.
Oh,
That was
thank you.
impressive. Thanks so much, Chris. I think he makes a great point in reflecting back onto what Gabe said about the future environmental professionals. This type of opportunity could really open up those potential pathways, career pathways for our students. I also wanted to say something about Dr. Halley's work, because one of the things that I'm interested in too is how can corridors be used by wildlife? Our transmission lines, corridors, can they be used by wildlife as corridors? And I think a lot of his remote camera work can help answer those questions. So thank you very much, Chris. And our next speaker is Ben Ballard, who's here from SUNY at Morrisville. And yesterday he spoke in the afternoon about some of his research in detail, some of the work, but he's been part of a network that has just been amazing in New York State, really managing rights of way, in my opinion, in the right way, using IVM over long periods of time. He's been working in rights of ways for 22 years, is what I have written down, and is doing some excellent work focusing more on the vegetation response, vegetation management part of his research project. So, Ben.
Good morning, everyone. We're probably all about ready for a break right now, so I'll not drone on for too long. But I wanted to share a little bit of my experience, our experience. I've actually worked with Chris Nowak at SUNY ESF and industry partners for, as Carolyn said, since around 2000. And today I'm going to kind of share with you some of the current work that we're doing with New York Power Authority. We've actually had ongoing research with New York Power Authority for that full 22 plus years, along with a bunch of other utility partners in New York State. And as an academic, we even did work and research with, the chemical manufacturers, but don't tell anybody, right? I mean, so the key for me, and from my perspective, everything that's been shared here is great. One of the things Lou and I have done over the last 20 plus years, along with Chris Nowak, we actually sit down, we're on our next cycle, so I'm going to share you a little bit about our next cycle of research. We actually sit down and we do a little bit of brainstorming, and we really are working with Lou to say, Lou, what are your pressing issues right now? What are the things that are, what are you doing in the field operationally? Have you changed things? What regulatory things are coming down the pipeline? What issues are you having with permitting? Are you having stakeholder issues, right? So we try to identify what are kind of the critical areas, and then are there things that we can do to look at it from kind of a third-party outside view, document some of that, quantify some of the things that Lou might be observing in his operational treatments. Sorry, Lou, I didn't mean to pick on you the whole time, but we could pick on Kevin. Is Kevin still here too? Your predecessor? So with that, I'll just take you through some of what we're doing in this round of research that we have planned for the next 5 years. And of course, if you're interested in the things that we've done over the last 20 years, a lot of what we've done, we've actually shared at these conferences. So if you go back through the proceedings for the last 4, 5, 6, or 7 proceedings, you'll find work that we've done on a whole range of topics. This current round of research that we're doing, in fact, the one that I shared yesterday in the afternoon was a project that we finished up over the last year or so, looking at sapling growth rates. And so this was tied to the FERC or NERC requirement, basically saying you should be setting your cycle lengths based on your growth rates for your vegetation, at least in part. And so to answer that question for Lou, we said, all right, what are the top 6 to 8 species that we find on power line corridors in central and upstate New York? And then based on that, worked out a sampling strategy, used undergraduate and graduate students to do the vast majority of the field work, collected that data, and then at the time, I've actually had got another job doing other things, teaching people how to become renewable energy installation service and maintenance technicians to design those systems, right? So that's my normal everyday teaching job, and then I get pulled in on summer projects and have been for the last 5 to 7 years with Chris. We said, we've got this data set, what can you do with it? And so it was my job to answer Lou's question based on all that data that was collected by our students. So that was one example of kind of a practical question that we were able to answer in a relatively straightforward way. We've also got work ongoing here looking at invasive exotic plants and their management on right-of-ways, answering questions like what is their suitability for pollinators. We've been involved in research in Ohio with First Energy and EPRI, looking at pollinator work, kind of complementing the work that's being done by some of my colleagues up here on the stage. And then one of the neat projects that I'm kind of excited to get involved with, Lou's got this great data set from 1999 to present of operational data. So they've gone through and they've done annual inventories of all their lines, so they know what is there, what are the densities, what's the species composition. This is all geo-referenced. And they've played around with that data a little bit. In fact, in previous conferences, they've shared some of their operational trends. But Lou knows, New York Power Authority knows they've got more information in that data set that could probably be teased apart by somebody that knows something about how to manage and then analyze large data sets. So that's one of our projects that we're going to work on over the next 5 years. And that's one where we don't really have any preconceived notion of what we're looking for or what we're going to find. But working with partners like Lou and New York Power Authority, they know that we've got a good track record over the year of usually delivering more and more value than what we said we were going to from the beginning. So in this case, I promised nothing. So I'm pretty sure that I can actually exceed that expectation. One of the other projects, and you can tell, I kind of like to joke around. One of the projects that we have ongoing, this is actually kind of picking up where Lou has started. And on operational treatments, they've started mowing directly under the conductors in some places where access might be a problem, or they have issues with line clearances. And so these are relatively narrow mowing strips, it's like 10 to 15 feet wide, directly under the conductor. So 3 strips mowed into corridors that might be pretty heavily populated like this one, fairly dense shrub communities. From an operational standpoint and working with the guys that are out there with the backpacks every day, this is actually a great thing for access, to be able to get in there and actually target those tall growing tree species without spending hours crawling through the brush, literally. And so what we're interested to find out is, what's this going to do to the vegetation dynamics over the long term? And are we potentially creating problems down the road? So by mowing these areas directly under the conductors, and in some cases going in with a follow-up herbicide treatment to convert this over to an herb-forb mix that might have some additional pollinator or other wildlife benefits, as we're doing that, are we creating some potential problems with the tall growing tree species? Are we creating more opportunities for those trees to get established? And so part of what we're going to do is just document that. And then this will create some additional opportunities to look at things like pollinators and wildlife habitat and other research topics. So that's just one example of a study where New York Power Authority came to us and said, we think this is a good idea. In fact, we've had that conversation kind of going back and forth for quite a while about access and doing things directly under the conductors, kind of modifying that wire zone, border zone approach a little bit. One of the other things that I think is probably a benefit to the utility, and you can talk to Lou afterwards and find out if this is true or not, but I'm pretty sure it is because we talk about this on a pretty regular basis. The education and outreach piece is actually pretty important. So one of our quote-unquote studies in this round of research is actually focused on education and outreach. So that'll include things like developing fact sheets, and some of you have probably seen some of these. In fact, I think there are at least 6 of them that have been kind of modified, adapted by UAA, and they're available. If you're a member, you can go onto the website and search for fact sheets, and some of these will pop up. They're really geared towards enabling right-of-way vegetation managers to engage with their stakeholders, engage with the contractors that are doing the work on the right-of-way. And so we've got a whole range of topics, 15 different fact sheets that we've done so far, and we got another 4 to 6 of them planned for the next 4 or 5 years. Again, really focused on what are the things that Lou needs and his crews need to be able to do their jobs more effectively. It might be training new crews. You get spray crews that there's a lot of turnover in some of those crews, so how do you get those new people on the crew trained up to do some of the things that we tend to take for granted, like plant identification? Is that a desirable or undesirable, a compatible or incompatible plant? We kind of take that for granted. And so in the past, we've done workshops, sometimes just half-day workshops. We'll go to the field, we'll actually meet with the crews in the field, and we'll just do a quick plant identification workshop. And so that's another example of outreach, in addition to having these 1-page or 2-page fact sheets that you could hand to a spray crew or you could hand to a landowner to address various issues. So again, this is really directed based on what are the needs of utility and the vegetation managers to allow them to do their job most effectively. And for us, this is kind of a fun, easy way to share some of what we've done for research, or even just dig into the literature and pull information out that might be a little bit harder for some of you to do with all of your other responsibilities. You probably don't have someone on staff that can say, hey, go do some research. In fact, I think glyphosate's our next topic, right, Lou? Is to pull out some information on glyphosate and say, what do we know about glyphosate, and how do we have these conversations with homeowners or landowners or even spray crews or regulators? I told you I was going to keep this short. And so I would like to recognize New York Power Authority and our partners at New York Power Authority, as well as my colleagues, Phil Hoffmeyer, who teaches at SUNY Morrisville, and Dr. Chris Nowak at SUNY ESF. And I don't want to short any of our previous partners and sponsors. We've worked with almost every utility in New York State, a bunch of the chemical manufacturers, Electrical Power Research Institute, and many others. Again, thank you, and we look forward to your questions.
Remember how I said earlier that these successful partnerships come down to people? Well, Lou Payne is one of those people. I mean, he has been a champion of this type of research and partnerships in New York, and I feel like it's really become a model what they're doing in New York State. So thank you, Lou, for your continued support. And that's a message to all the industry participants here. It's not just industry partners, it's the people within the industry that provide the really powerful partnerships for us. So the last slide show, there should be one more. I am not Mark Scuschetti. Dr. Scuschetti from Jackson State University could not be here at this meeting, but he and I had a lengthy Zoom call, and I chose to put his presentation last. I'm going to go through it quickly, but a lot of what we've talked about has been really successful, powerful, long-term research projects. Here's an example of a project that created a lot of challenges for the researcher, and I think can be a lesson to all of us of how to improve or maintain good partnerships. So Mark is working, his research, although he's at Jackson State University, which is in Mississippi, his research plots were in North Georgia. So his research cooperator was a North Georgia cooperative utility, okay, so a rural utility. And what they were interested in is really, their primary interest was reducing costs. Could they go from mechanical maintenance of their right-of-way, and their right-of-way was located, it was a transmission corridor located along a road. Could they go from mowing it to herbicide treating it, and would that save money and reduce the amount of time that they had to treat it? So they told Mark that they were using IVM. Well, their IVM was just spraying every piece of vegetation in that right-of-way. So again, bring us back to that earlier definition. What do we mean by IVM? We need to be very clear what we're talking about. Also, Mark has still not received from his cooperator what was the actual herbicide they applied. He does not know what herbicide they applied. He also does not have any pre-herbicide application data. So I hope you're quickly seeing how his data, although he's working and he was working in good faith, he's not able to collect publishable research from this project. So the idea was, can this herbicide application save money? And secondarily, can it create some pollinator habitat? Okay. So this is an example of the right-of-way, this rural distribution. I think he said it was a transmission. I'm not sure if it was transmission or distribution line. You can see it's located along the road. You can see how they've sprayed instead of continuing the mowing. And again, non-selective spraying, which this company called IVM. His project study sites were located in the northwestern portion of Georgia, and they put up these native grassland and pollinator conservation area signs. It was a little disappointing to Mark because these were put up before the data. Like, this is the intent of the project, but we don't know if they were able to meet these intentions. So one of the great things, though, that I think came out of this project is Mark decided to take this pollinator report card that we've been developing, Penn State's been involved with developing, and he's made it into an app. So I thought that was really great. So he took these report cards, he apped it somehow. He said that is available for him to share. And he was not provided funding to collect the data. Excuse me, sorry. So he relied on industry to collect data. So the industry said, we will send our people out to the site every month over the summer, and we will use this report card to get a assessment of the habitat for pollinators since we've applied the herbicide. Okay, but there were no controls, no pre-treatment data, and what he turns out is then when he contacted the cooperator, they only collected data in May and October. They didn't go every month. They said they didn't, and that makes sense, right? This was not a priority of the company. They had other things that became very important during the summer, and they didn't have the time to send someone out to do these pollinator report cards. So we had data for May and October. Again, as we sit here as panelists, we understand how that is not really giving you a good idea of the pollinator community using that particular habitat. He also worked with the cooperators to use drone imagery. So one of the ideas was, if you use herbicides, do we see the response from the plants? Can we go and run drone imagery and, excuse me, and see if the plants respond in the same way that they would if they had just mowed it? Okay, so let me just get my coffee. You can take a look at that. Here are the data that were collected. Again, these were just some quick data that were collected, not in any detail, by industry and then some interns. So Mark was able to get industry to fund 2 of his students as interns. So they went out and they just collected general data about what they saw on using this herbicided transmission line. Okay, so did they see a wasp on a flower, moths, flies on flowers, et cetera? They did this for 2 years. This is the first year of data. And these are the second year of data. Okay, so in the second year, they saw 1 monarch butterfly. Okay, so are pollinators using this piece of landscape? Yes. Were they using it before they treated it? They don't know. Will these numbers increase? They're not sure. And they don't know really what was going on during the summer months. Now the interns, though, to be fair, when they were out, the interns and some of the people who were that were working for the cooperative did take pictures, so they do have a nice photographic atlas of wildlife, plant response, things that they found along the rights-of-way. Again, it's incidental data, but there are some data of different species, different plants that they found along this right-of-way. The drone imagery. Okay, so he also looked at drone imagery, and what you're seeing at the bottom as that image changes, this is now post-treatment. So what they're trying to see is how did the vegetation change dramatically from pre to here is the post-treatment. Are they able to maintain this low-growing vegetation communities using the herbicides? Well, and this is also using normal distribution veg index, using some other different color imagery. What they're trying to see is, did they reduce the red? So the red is considered incompatible, high vegetation that potentially would be non-compatible with the rights-of-way. So they did see that that was maintained. You can see there's a little growth here on the left, but they were able to keep most of that red out of the rights-of-way. However, the cooperators only took drone imagery in December. So he said to them, he said, how do I know if I'm really just seeing a seasonal signal of vegetation? I said, well, that's when we ran our drones. We ran them in November, late October through December. That's the data we have. So, here's an example of very limited findings. Mark can say, yeah, there are pollinators on the rights-of-way. They're there. They seem to be increasing. We got 1 monarch in year 2. We had 0 in year 1. Again, that's not statistically relevant at all. Anecdotally, the utility is saying over the 2 years of the project, they've had reduced utility outages. Well, really, shouldn't we be looking at storm events and other things to see what's actually happening there? And he really just said there really was a lack of real commitment from his research partners. There was not insufficient investment. There was not this commitment to actually doing the study as designed by the academic researcher. He has no publishable results, and there was institutional resistance because of turnover. Again, I'm going to bring this back to people. So again, when Mark started the project, he was working with a completely different person at the cooperative. That person moved on. Project did not become a priority. Mark worked his way through it, collected the data that he could. But this is what happens when we don't have that real commitment with people and with resources. There was no funding at all for the faculty. The private partners, this cooperative, were willing to fund 2 interns, but they would only pay for certain hours. So again, they really couldn't do the collections that were necessary. And he tried to improve this project through grant proposals to the Tree Fund. So he was trying to look for his own sources of funding, but that grant proposal was unsuccessful. So that's a study. I didn't really, my conversation with Mark, I was a little disappointed in hearing his experience because mine, and I think the rest of the panelists, has really been so positive. So I want to finish our panel today with just this slide that I put together last night after talking with the panelists. And I wanted to start off by talking about how can working with academic help the utility industry. Well, there happens to be still a lot of public trust in the university institutions. And I will say in particular with these land-grant schools that are like associated with the identity of a state. When you talk about Penn State in Pennsylvania, and people immediately identify with it. I know Dr. Carnes has talked about the Block O. If the Block O of Ohio State recommends something, it has a lot more credibility. So there's this public trust, data-driven support for the management approaches that utilities are often implementing. We also can provide education and outreach for the public, for veg managers at the utilities, as Dr. Ballard mentioned, students, our own students, students that you may hire, regulators, policymakers, and I would also say we're potentially training the next generation of environmental scientists that could work for industry, if industry decides to hire ecologists, for example. But on our end, what we need for these projects to be successful is real, so real committed, that means committed up front, usually with some sort of agreement between the university and the industry, multi-year financial support for publishable, peer-reviewed data. We need control sites, we need consistency of management, we need to know what you're doing. We've been at meetings sometimes and we hear like this little off conversation about, oh yeah, we went into your sites and we treated some red oaks that were getting too big. Well, if I didn't hear that conversation, I wouldn't really know, okay, there was a herbicide treatment within the 5 years. We're not judging industry, we just have to know that so that when we interpret our data and represent our data to the scientific community, we are doing it with the correct information. The partners and people are critical. I think you have seen that through this presentation this morning. Really critical to get the right people on the industry and on the academic side. Our research results also, and this is something that's really important to me, when you're working with groups like Marathon, which for better or worse have a reputation among our students, we need to be able to say to the academic community, our peers, the scientific community, our work is independent. All of my research partners sign an agreement with Penn State that I can publish any of the findings that we have. There has been no restrictions at all on the findings that we publish in our research. We don't even send the papers through our partners before we send them out to the journals. So that's what you need. You need this independent, publishable research. Publicly reportable as well is really important. And I just want to end here, and then we'll have about 15 minutes for questions. We have to really talk frankly about IVM in practice versus in theory. Our research is showing that IVM works. It works for wildlife communities that need that particular type of habitat, pollinators, butterflies in particular, early successional birds. But we're not always clear on what is actually being done. That particular example from Jackson State shows he was being told that they were doing IVM. Really, they were just changing from mechanical to non-selective herbicide treatment. So we all have experiences where we have visited sites that we thought were being managed by IVM. We get to the site and we see compatible species have been sprayed with herbicides. So it comes down to training, which is on us as well as on the utilities. So with that, I'm going to be moderating the panel. So I would like to open this up to questions. Yeah, okay. My clock is different than yours, Travis.
Yeah, it says we have 12 minutes.
Our
left.
clock is different. So let's get some questions here, and then we can direct them to the panel. So yes, right there in the gray hat.
So I work in GIS, so I'm going to talk about the S word, scale. What
Yes.
kinds of geographic scales, maybe it's life history strategy, for example, like a bee, how far can it fly to forage? Do you see in your work, and how can we kind of think about these spatial scales, not only longitudinally down the right of way, but laterally off of right of way in terms of managing?
Yeah, I think we actually discussed this yesterday. I'm not sure which of the panelists would like to address that,
I can do
maybe.
it too, but you go.
Okay, we'll start with Kim and then Gabe.
Well, no, I mean, one of the things that I didn't really talk about is trying to estimate the potential benefits of having the rights of way in a particular area in a landscape scale. Like, are the bees just hanging out in this happy habitat? Or are they actually moving off to give pollination services to the surrounding areas? And trying to see, how far reach they have. And so, I am trying to investigate that with a certain study design of mine to see the impact of management. And, it's still a pretty local scale because, again, I'm sort of focusing more on individual, providing habitat for the bees and living in there and how far off individuals are going to go. But I think, it really just, calls to a nice GIS analysis looking for the proportion of right-of-way managed in a certain way and sort of a landscapes, scenario where, are we seeing the impact of that on a broader scale? And I think there's some work in Europe going on to that, to that effect. Anyway.
Yeah, so if you came at it from a benefit, we've looked at impacts. Ecologists are quick to throw out big round numbers with lots of zeros behind them when we scratch our head and aren't really sure what the true answer is. So it's like, what's the edge effect that would negatively impact salamanders along a utility corridor? And quickly, if you look in the literature, there's big round numbers like 100 meters, which is oddly specific, right? You put out micro moisture probes and you document sort of this curve of thermal and wind exposure. And what we found in Ohio is that negative impact of microclimate that does lead to a differential in habitat suitability for salamander is like less than half of that. We do not find very many salamanders at all within 30 to 35 meters of the right-of-way, but as our 4th and 5th and 6th cover board at 40 and 50 and 60 meters away, we see that microclimate plane out and return to what is possessed within the forest interior, and we see that salamanders are living and occupying space right up to that buffer of tolerability. So in that case, actually collecting data, all of a sudden, the footprint, which may be a negative impact to salamanders, is actually only 1/3 of the numbers that we previously threw around because we simply didn't have data. Those research projects are invaluable because otherwise we're really shooting in the dark and making an educated guess, but undoubtedly a guess that's wrong.
Yeah, and I'll just say, we found that too with as long as our sites have border zones, we really lessen the effect into the surrounding forest. We have salamanders on our rights of way in those border zones. So, yeah, he's exactly right. Another question, please? Okay, one more in the back.
Yeah, Carolyn, Rick Johnson.
Oh, hi, Rick, yep.
I do want to say for the academic community, you know, we work with Gabe on the studies he's doing in Southeast Ohio. And oftentimes the university will go off on their own tangent without discussing with the people in industry who have been doing it and know what works and what doesn't work. You know, like, you know, taking drones in December, who cares, right?
But that was an industry decision, not an academic one.
I understand it, but how they do define what the parameters are, what they're going to study. I do want to say that some of the industry is getting on board. We're down here, and we're going to talk on what we're talking about here at 10:30. But Piedmont Natural Gas here in Carolina contacted me a couple weeks ago and said, we want to start doing IBM. And I said, well, let's establish some baseline data so we know what you have now, because they've been mowing every year. And I said, stop mowing a few places, let us go in and document what's there, and then we can show you how it changes going forward. So we need that
Yeah.
back and forth, which, you know,
I think.
when we're at State College, you guys had that.
I think, Rick, you're exactly right, and that's why it's the people on both sides, right? It's not just the industry people, it's the correct academic personalities, people who are willing to work with this applied research approach. I want to say this, even though Travis says there's no time left, our clock says 7 minutes, so I think the panelists, we'll just kind of hang out here, so if there's people in the audience, utility representatives that just want to talk to us over that break time, we're happy to talk to you, so just come on up and chat with us, and we will hopefully be able to answer any of your questions. So thanks for coming out this morning.
Sorry to be the bad guy. But it's obvious all of you are very passionate. Yeah, our clock up here is different, so we'll have to get somebody to work on that. So my apologies to you all. I think that we learned a lot. I think there is tremendous opportunity and potential funding. I know as an industry person and working with a lot of you that there is a lot of interest out there among different types of practices and what impacts they have. And I think building collaborative partnerships does pose a tremendous opportunity. And I hope some of you will take advantage of having these academic colleagues here and learn and talk with them about potential opportunities in your area. So it seems like there should be another number up there. Shouldn't there be another number? Okay. Okay. So in the meantime, I guess we do have time for another question. Does anybody have a question? Okay.
We're here to chat with you too. We'll hang out here, so. Oh, yeah.
On measuring the habitat, there is a give and take. We're using what Dr. Doug Calamy's group developed at the University of Delaware through lepidopterans.
Yep.
And then we've worked on with others and developed one for bombus. And so we can actually graph the benefits to those different insect groups simply by the type of flowering plants that are in the right of way. We're not looking for bees.
Right, you're looking for the plants, yes, that's,
Saying these plants produce good, high quality nectar and pollen, and that's important to these
yes.
insects.
Yep, and I think we're starting to look at those correlations, and that's really important, Rick, to look at that, yeah. All right.
I know Dennis left to try to go get the number for those of you that are sticking around. I think so.